Okay, so what is everything?
Alright, here's our wheel assembly. We have an independent wheel system where we have one wheel mounted to each corner of the robot. The wheel assembly started out as two big pieces of 6061 aluminum. Pretty much there is the back half and there's the front half. The front half, back half are joined by two 5/16 18 bolts, and the two bearings actually locate together by using two pins, so the two halves are located and seated properly for the axle to slide through. For the front half, pretty much we have a bearing bore where we have a sealed bearing pressed into each side, and on the rear of it we had to cut out a little pocket for adjuster. We actually have an adjuster that mounts to the front of this, where it actually, a bolt slides through and holds an adjuster which we could adjust our belt with the tension. Because we're using a timing belt system, we have to adjust the tension somehow because we can't get it perfectly tight. Besides that, we just did some of the lightening just to lighten it up a little, and we're going to do some more lightening soon. The back half pretty much houses the motor. It has the bore diameter of the motor, so it goes ahead and each one holds an individual sim motor. The two sides bolt together, the motor slides in, and then you can bolt it up to the original sim motor bolts. On top right here we have a bolt pattern that goes ahead and mounts the, I don't know exactly what you want to call it, maybe a throughput shaft or something. This bolts to the top, and we have a little bit of room on the bottom for our thrust assembly, which is a bearing that allows this thing to spin and rotate. And then through the actual chassis we have bearings that are taking up radial loads side to side. So here's another part that we had made. It started out as a solid. We had turned it down to the right size, drilled the holes in the mill. The actual outside was done on a lathe, and then all these holes were done in the mill. And this was turned down by hand manually and died, and we turned these down for the gears to slide over so we could have steering capability. So this was the front and back. This one had a sealed bearing on that side too. To assemble these things, pretty much the two halves bolt together with some socket head caps. We have our wheel assembly. Had our wheel assembly.
Come on!
Okay, so we have our wheel assembly. We machine these hubs as well. They pretty much slide through and bolt on with 6 socket head caps. These holes are just for lightning. And then we have some cross-drilled holes that are drilled all the way through to the center. We put some 1/4-20 set screws so we could actually pin the wheel onto the shaft. Here is our bottom wheel. It uses an XL series timing belt. This bottom is a 60 tooth, and we're using a 10 tooth for the top, so it makes it a 6-to-1 reduction. We had to machine this little piece of sheet metal, put it on the front so the belt doesn't slide off because this only had a single flange. Here's our top pulley, same thing, XL series, 10 tooth, has a set screw to hold on, and this one already was double flange, so we didn't have to do much. And here's our shaft that we made. It was just made out of just normal ground steel, which is 3/8 diameter. It already had a flat ground into it, so we could set all our set screws and not have to worry about it slipping. We made these little mounts that we were able to bolt the US digital encoders to. So each wheel has an encoder built in, so we could actually use it for traction control to make sure all the wheels are actually spinning at the same speed. And if they're not, we could make adjustments to the motors to slow them down or speed them up to keep them all the same.
That's it?
That's it.
Any last words to the girls?
That's going to be it. I just recommend everybody to get a Winnie the Pooh umbrella, and that's about it.
Thanks, Bob.